determinant alpha, alpha square, beta plus gamma, beta, beta square, gamma plus alpha, gamma, gamma square, alpha plus beta. We have to prove it equal to the product of four factors, beta minus gamma, gamma minus alpha, alpha minus beta, into alpha plus beta plus gamma. Take left hand side, rewrite it as alpha, beta, gamma, the first column, alpha square, beta square, gamma square, the second column, beta plus gamma, gamma plus alpha, alpha plus beta are the elements of third column. Now look at it very carefully. And the right hand side, the factors you want. What if you add C1 and C3? You get alpha plus beta plus gamma. All the elements of C1 replaced by C1 plus C3 will give you alpha plus beta plus gamma, which in the next step we can take common. So you replace C1 by C1 plus C3. We get alpha plus beta plus gamma, alpha plus beta plus gamma, alpha plus beta plus gamma. The second and third column will keep as such. The elements of second column are alpha square, beta square, gamma square. In the third column are beta plus gamma, gamma plus alpha, and alpha plus beta. And now clearly we can take alpha plus beta plus gamma common from C1. So taking alpha plus beta plus gamma, this factor, common from column 1. You get alpha plus beta plus gamma outside. The elements of column 1 will be 1, 1, 1, and column 2 and 3 will maintain as such. Beta plus gamma, gamma plus alpha, alpha plus beta. And now because you get 1, 1, 1, you need not to worry what factors, what other factors you really require. But this 1, 1, 1 gives you the clear hint that by applying R2 minus R1 and R3 minus R1, we can get two zeros in column 1. So when in column 1 you have 0, 1, 1, 1, we should apply here, that is replace R2 by R2 minus R1 and R3 by R3 minus R1, of course keeping R1 as such. So already you have a factor alpha plus beta plus gamma outside and applying R2 minus R1. So keeping R1 intact. What are the elements of R1? The elements of R1 are 1 alpha square beta plus gamma. Now R2 minus R1 gives you 0 beta square minus alpha square, and you get here, actually you get alpha minus beta, but if you take minus common, that will make it beta minus alpha. Why we are doing so? Because the second element, which is beta square minus alpha square, when factorized will give you the factor beta minus alpha, beta plus alpha. So even to the third element, instead of writing alpha minus beta, we are writing minus times beta minus alpha. And likewise in the third row, you have 0 gamma square minus alpha square, and you have alpha minus gamma. So you take a minus common here only to make it gamma minus alpha, so that we can take it common from row 3. So now taking beta minus alpha common from R2 and gamma minus alpha common from R3. So you have beta minus alpha into gamma minus alpha. Alpha plus beta plus gamma is already a common factor. So you left with the first row as such, that is 1 plus alpha square and beta plus gamma. Now from the second row, when you take beta minus alpha common, you get 0. What are the factors of beta square minus alpha square? Beta plus alpha, beta minus alpha. So beta minus alpha you have taken common, so you left with beta plus alpha. And in the third element of row 2, you'll have taken beta minus alpha common, so you're left with minus 1. And now taking gamma minus alpha, likewise common from row 3, you're left with 0, gamma plus alpha, and minus 1. And now obviously we should expand at this stage the determinant along column 1. So expanding the determinant along column 1. Already you have the factors outside, you know, alpha plus beta plus gamma, beta minus alpha and gamma minus alpha. Out of beta minus alpha, if you take minus common, you will get alpha minus beta, because we need alpha minus beta, beta minus gamma, gamma minus alpha as such is okay, and the other factor alpha plus beta plus gamma. And now when you expand the determinant, you get 1 time, beta plus alpha minus 1, so minus times beta plus alpha, and minus minus plus times you get here gamma plus alpha. So open the bracket. Already you have minus times alpha minus beta, gamma minus alpha, alpha plus beta plus gamma. Inside the bracket you get minus beta minus alpha, and you get plus gamma minus plus alpha, plus gamma plus alpha. So alpha cancels and you get minus beta plus gamma, but you need gamma minus beta, so take another minus sign common, so minus and minus will make it plus, alpha minus beta, and from inside this bracket, because you have taken minus common, so you get beta minus gamma, gamma minus alpha is already there, and alpha plus beta plus gamma factor is there. So finally you get the value of determinant as required right hand side as alpha minus beta, beta minus gamma, gamma minus alpha, and 2 alpha plus beta plus gamma, that is the required right hand side.